Hi everyone, these are the Calculus section 6.5 notes about the average value of a function. I'm going to define what the average value of a function is, but first I'd like to write it out for you. If f of x is continuous over a closed interval a to b, then f AVE is the little subscript. That means the average value of f is equal to 1 over b minus a integral a to b f of x dx. And I'm going to do a problem algebraically with you and explain what that average value is. So let's all write down, find the average value. This means the average value for the function f of x equals 1 plus x squared over the interval -1 to 2. So what we're going to do is we're going to follow the formula. So the f average is going to be 1 over b minus a, 2 minus -1, integral -1 to 2. And then we put our f of x here, dx. And then we start doing the algebra. So this is going to be 1 over 3. I'm going to go ahead and anti-derive 1 plus x squared. That'll get me x plus x cubed over 3. We are evaluating that between -1 and 2. So we'll get 1/3. Now I'm about to FTC, plug in a 2. That's 2 plus 2 to the third power is 8 over 3 minus, in parentheses, plug in a -1. So -1 into here, -1 into here, minus 1/3. All of that gives me 1/3 times, all of this together, when you add everything up, gives me 6. So 1/3 times 6 is 2. This answer is the average value. Now, what does that even mean? Okay, AKA F average. This is the notation. It looks like fave, but it's F with a subscript of AVE, meaning the average value of F. And it's 2. So if you think about the parabola, 1 plus x squared. 1 plus x squared. That's a 1. It's basically the parabola moved up 1 unit. And this is -1, and let's say this is 2. So let me just kind of extend this. And if I drop 2 vertical lines down, you all know that the integral, this part, means the net change under the curve, so basically all of this. Now this has some net change, some area. Okay, the net change in the area would be the same here because there's no negative space. 2, so if this is 1 and this is 2, is the height. It's the height of one rectangle going from -1 to 2. The height. So if I were to sketch a rectangle with a height of 2 over this entire interval, one single solitary rectangle, okay, then the area of that rectangle would be the exact area of the green shaded stuff under the curve. So the rectangle and the area of this region are the same. So 2 basically is the height of that rectangle that would make the rectangle and the shaded region have the same area. Okay, so then we've got MVT for integrals. If you remember, MVT is the mean value theorem. For integrals, this is what it says. If f of x is continuous over the closed interval a to b, then there exists a C value such that f of C equals f average. Okay, so let me do an example so you know what MVT means also. Sorry, let me get my notes together. Here we go. Example. Find C such that MVT for integrals is satisfied. And I'm going to use the same function and the same interval. So what we would do is, first of all, we need to, this is the formula we're going to do. We're going to let, this is a comma, it's not f prime, I'm so sorry. It's f of C. So again, f of C equals f average. Okay, this is MVT. So f of C literally means just plug in a C here. 1 plus C squared, set it equal to f average. We actually did f average in the above problem, okay? And it was 2. So set it equal to 2. C squared equals 1. C equals plus or minus 1. So what that means is so let me redraw, sorry. So if this is our parabola, and this is -1, 1, 2, either at -1, okay, or at +1, sorry, this is 2, or at +1, when you draw that rectangle, you will get a height of 2. Okay, so C tells you, so this would be in the above picture, there are 2 locations where at -1, the height of the parabola is 2, and at +1, the height of the parabola is also 2. If you're doubting yourself, plug in a 1. 1 plus 1 squared is 2. 1 plus -1 squared is also 2. So basically, you cannot do MVT for integrals unless you have the average value first. All right, so the last thing I want to say is, what if I asked you to, so example, about where is C for MVT for integrals to be satisfied? Okay, so I'm asking you to guess. Look at a picture like so. Let's say this is A, this is B, and there's some curve like that. Drop the verticals. Okay, and think of the shaded region. Now, this shaded region has some area. Where would you estimate the C value to be? Basically, that's where I would draw the top of the rectangle so that the rectangle would have the same area as under the curve. First of all, for me, that would be smack dab in the middle. I would say this is one value of C, because if I draw the height there, I would say that this rectangle right here has the same area as the red shaded area, because this piece and this piece look identical and they kind of cancel each other out. I would say that's one place. Another place would be here, because that height looks like the same height as this, so I'd call that C2. And then I'd say there's another one here because this height and this height and this height are the same. So I would say there are 3 different C values in this function. This one, and this one, where if I draw the height of one rectangle up to the curve and connect a line at the top, the area of that green rectangle would equal the area of the red shaded space. And that's the end of average value.